So hopefully you guys jotted down this class opener in your notes, especially because you need to have these in your notes with the title, date, and day. Class opener, put today's date and the day. And the reason why I put number 1 up here is because surprisingly there were a handful of people that missed this easy type of question on the last test. We are not multiplying because there's a sign between the parenthesis and the number. And not only that, whenever you do have a minus minus, you need to change it to plus plus even before thinking of money. And now you could actually say, okay, I owe $3, I have $5, I could pay them off, I will have $2 left over. So the answer is 2 on number 1. Now if you look at numbers 2, 3, 4, and 5 on this class opener, they're all the same type of question. They're all related to the same concept, a very important concept that we need to know today when we start solving equations that have fractions in them. So the concept is, when you multiply a number by a fraction, how do we do that? We put it over 1 and then simply multiply the top with the top. 2 times 1 is 2, and the bottom with the bottom. 1 times 2 is 2. And it is negative because a negative times a positive is a negative. So your answer is the fraction negative 2 over 2. And 2 over 2, 2 divided by 2, that's 1. So the answer is really negative 1. Now, the idea is you could have identified this 2 up on top and this 2 on the bottom, and the 2's cancel. That 2 cancels with that one, and it really becomes negative 1 times positive 1, which is negative 1. Okay, so the idea or the concept that I want you to understand here is that whenever you multiply a fraction by a number that's the exact same value as the denominator, it'll cancel it out and you'll just have the numerator left over. Okay, let me repeat that and let me try to say it nicer. When you multiply a fraction by its denominator, the fraction disappears. One more time. When I take a fraction and multiply it with its denominator, 8, the fraction disappears. The 8 cancels with the 8. The answer is 3. Isn't that easy? And we will have to understand that and remember that when we're solving 1-step and 2-step equations today. Number 4, again, when you multiply a fraction times its denominator, the fraction disappears. Now, of course, if you wanted to explain it the long way, you would say, okay, put the 5 over a 1, 2 times 5 is 10, 5 times 1 is 5, 10 divided by 5 is 2. But we know that when we multiply a fraction with its denominator, those cancel out. 5 divided by 5 is 1, it'll cancel out, and the 2 is left over. So when you multiply a fraction times its denominator, the fraction disappears, and the numerator is all that's left. What's the answer to number 5? 3. And you don't even have to do any math. It's just, the denominator's 4, this is 4, they cancel out. The answer is 3. So I just did that quick class opener because we will need to apply that skill today when we're solving 1-step equations. Let's move on to today's lesson. So up until this point, we've only been simplifying expressions. What does it mean to simplify, to make it more simple? And we've learned that we could simplify doing 2 different things: distributive property and combining like terms. And here's an example of that. We're going to simplify 2x plus 3 minus 5x. We can't distribute, but we could combine like terms. We could combine this 2x with this minus 5x. And when I combine those, what do I get? If you have 2 and you owe 5. Negative 3, and we're talking about those same exact x's, right? It's like having $2, owing $5, you owe 3 of those dollars. You can't pay them off, you still owe 3. And then the plus 3 that's left over, you simply bring it down. And that's what we call simplifying. Today, we're actually going to start solving equations. And what are equations? They're variable expressions that do have an equal sign. Up here, there was no equal sign. Down here, we do have an equal sign. Again, the word equa inside equations reminds us that we need an equal sign for it to be an equation. So what is an equation? An equation is kind of like a balance, right? We have a balance right here. And whatever you have on one side, like right here we have nothing, so it's perfectly balanced. Now what if I took my face right there and put it, it would cause it to go off balance. Does that make sense? So right now, let's just put it back. See, it's off balance unless I take another one of these guys right here and put it right there, and then it would cause it to be, oh, this is all messed up, sorry. Especially if this face is bigger than the other. You guys get the idea. Whatever you do to one side, you have to do to the other. So if I put another one of these guys right here, it would be off balance until I do the same to the other side. Make sense? So an equation, you have to think of it, the equal sign means that it's perfectly balanced, equal weight on both sides. Now, if I happen to take one of these away, it's no longer going to be balanced unless I take one of these away. Make sense? So the key concept to an equation, you can do whatever you want as long as what you do to one side, you do to the other side. So if I add one here, I have to add one there in order to maintain the equality. Okay, so that's the first and most important thing that you need to know about an equation. The equal sign is telling you that both sides are equal. You could imagine a weight, right? They're equal in weight. So if you take one away, you have to take one away from the other side. If you add 2 here, then you have to add 2 over here in order for it to maintain balanced. Okay? If you take 2 away, you have to take 2 away. So whatever you do to one side, you do to the other side. And that's a very important rule, the most important rule of equations. Whatever you do to one side, you have to do to the other. And that's true even if we talk about just regular numbers. Like, give me a number.
37.
37 equals 37, right? It does. Now, what if I were to subtract 7 here? Will it be balanced? No, unless what I do to one side, I do to the other, right? Then it'll be balanced, right? But you could do anything you want. Not just adding and subtracting. You could divide by 10, right? Divide by 10. And what you do to one side, do to the other side, and it'll remain balanced. It'll remain, the equality will remain there. So you can do whatever you want to one side of an equation as long as you do it to the other. If you want to, even if you wanted to square that side, you could square this side, it'll be 9 equals 9. So whatever you decide to do to one side of the equation, you have to do to the other side of an equation. So that's the first most important rule. Let's jump to the part of our notes here. Again, right here it says whatever you do to one side, you must do to the other. Now it says right here the goal of solving any equation is to get x by itself on one side. Okay? How do you do that? If you want to get rid of something, you must do the opposite, right? If there's a fire, you turn it off with water, right? If there's a +3 and you don't want it, you're going to do the opposite of +3, which would be a -3. If there's a ×2 in front of the x and you don't want the ×2, you'd have to do the opposite of multiplying by 2, which is what? Dividing by 2. Okay? So whatever you do to one side, you have to do to the other. And if you want to get rid of something, because the goal is to get x by itself, if you want to get rid of something, you have to do the opposite. And remember, what you do to one side, do to the other. So number 1, I'm going to get rid of that +2 by doing the opposite of +2, which is what? -2. Now, some teachers like writing the -2 to the side. I like it right below. Okay, so I'm showing right here +2 -2. That ends up being 0. 2 take away 2 is 0. I'm just going to put a line through it. What I do to one side, I do to the other side. And then over here on the right side, because remember, if I don't do it to both sides, it's not going to be balanced anymore. So if I subtract 2 from one side, I have to subtract 2 from the other side to maintain the balance. Now right here I have -8 take away 2. What do I get? -10. You owe 8, you owe 2, you're going to owe 10. Now notice this equal sign is going to come straight down, and this x that's left over is going to come straight down. So I have x equals -10, and ladies and gentlemen, that is my answer. Why? Because the whole purpose of solving is to get x by itself. And I got x by itself. It says x equals, I'm done. Now if you wanted to double check your answer, all you have to do is take -10, plug it back in here, and see if it actually gives you a true statement. -10 right in here, +2. If you owe $10 and you have $2, you're going to owe $8. So you could mentally plug it back in and double check and make sure that negative 10 is the correct answer, which it is. Number 2. Now, how do I get rid of this minus 2 right in front of the x, or this negative 2 right in front of the x? Okay, right there we are multiplying. So you have to get rid of the multiplication. So you do the opposite of multiplication, the inverse operation of multiplication, which is division. So once again, let me show this. I'm going to put a dot right here because it's really multiplying between the negative 2 and the x. And you need to do the opposite of multiplying, which is dividing by negative 2. Okay? That will cancel it out. Now, some people might say, just divide by 2. Hey, but what happens with that negative sign? It doesn't disappear. You want to get rid of the whole thing negative 2, divide by the whole thing negative 2. And of course, right now, it's off balance, right? So whatever I do to one side, I have to do to the other side to maintain the balance. So that would be negative 2 over here. So my answer is x equals positive 4, because negative 8 divided by negative 2 is positive 4. Number 3. Let's get rid of, remember, the goal is to get x by itself on the equal sign. So Isaac, if I asked you, where's the x at? Is it on the left side of the equal sign or the right side of the equal sign? Where is it at? It's on the left side. Is it by itself? Heck no. There's x right here, and then there's a divided by 3 right below it. Or you could think of it, this is a fraction. And remember on the class opener, when you multiply a fraction by its denominator, it'll get rid of the fraction. So in other words, if you don't want this divided by 3, you do the opposite of dividing by 3, which is multiplying by 3 by that denominator, and it will cancel out. However, right now it's off balance until I do it to the other side. Whatever you do to one side, you must do to the other. So multiply by 3 over here. X is left over. The equal sign comes down. Negative 6 times 3 is negative 18. And we are done. That's the answer to number 3. Let's move on to number 4. Number 4, a lot of people get confused. It's as simple as this. I do not want a negative x. I just want x all by itself. I want a positive x. I don't want a negative x. So if I don't want this negative sign, what could I do? I could just change the sign, right? I could just say, I want to make it positive. I change the sign, but what I do to one side, I have to do to the other. So if I just change the sign on the left side, I have to change the sign on the right side. And my answer will be x equals negative 2/3. Now, that might be confusing to some. So let me go back and explain it a different way. What number is in front of the x? A 1 right there, right? So technically, this is a negative 1 right there, right? So if I wanted to make it a positive, well, I could either divide by negative 1 or divide by negative 1. I mean, what you should do to one side or do to the other. Or you could multiply both sides by negative 1. So it's up to you, however you want to think of it. So let me go back and just say, okay, I'm going to multiply this side by negative 1, and what I do to one side, I do to the other. Multiply that side by negative 1. A negative times a negative is a positive, and of course, positive 2/3 times negative 1, that'll be a negative 2/3. The easiest way for me to think of this is, hey, I want this negative x to become a positive x, change the sign. What I do to the one side, I do to the other, change this sign. So the answer is x equals negative 2/3. So I did 4 simple one-step equations. Now you guys try it. Go for it. All right, let's go through these. I did pause it, give you some time to do it, but right here, let's just explain it quickly. I want x by itself. I don't have x by itself on the left side of the equal sign. It says x minus 3. I don't want that minus 3, so I do the opposite of minus 3, which is plus 3. It's off balance right now until I do it to the other side. What I do to one side, I must do to the other. So yes, right here, 3 and a negative 3 is 0. So I have the x that just comes down, the equal sign comes down, and 2 plus 3 is 5. I'm done. If I wanted to double check it, I simply think, okay, x is 5. Here's 5. 5, take away 3. Does that equal 2? Yes, it does. I'm absolutely positive that this is the correct answer. Let's move on. Number 2, I really have 3 times x, right? If there's no sign between the number and the letter, you're multiplying. And if you want to get rid of that multiplication of 3, you're going to do the inverse operation of multiplying. How do you undo multiplication? What's the opposite of multiplication? Division. So we're going to put a division bar and that same exact value 3. Now, if this would have been a negative 3 up here, I would divide by negative 3, but that's just a nice 3. I divide by a nice natural number 3. Those cancel out. What I do to one side, I must do to the other to maintain the balance. And I do have an x, an equal sign, and 9 divided by 3 is 3. So that's the answer to number 2. Number 3, I do have a fraction here equal to 8. I want x by itself. I don't want this fraction. I need to get rid of this. Now, what is a fraction really? It's a division problem. It's x divided by 4. If I don't want this divided by 4, how do I undo that? Multiply by 4. So I'm going to put a little dot and I'm going to put a 4 up here. And we all know we don't even have to multiply. You just put a line through it because 4 on top divided by 4 on the bottom cancels out. But it is off balance until I do it to the other side. Whatever I do to one side, I must do to the other. So I need to put a times 4 over here. Now right there, 8 and 4 don't cancel. You're multiplying. 8 times 4 is 32. So x equals 32. Number 4. Again, you want x all by itself. You don't want a negative x. You want a positive x. I mean, so you could say, okay, I have a negative 1 right here times x. How do I get rid of the multiplication of negative 1? I divide by negative 1. I divide by negative 1. So this does cancel out. I now have a positive x. X equals a negative 5 divided by a negative 1 is a positive 5. Or you could have done the easy thing and said, okay, this is a negative x. I'm just going to change the sign. And what I do to one side, I do to the other. Change the sign over here. So x equals 5 either way. Now, that's what we're doing on today's homework assignment, WSP 2.2. Now, the next section after that is two-step equations. So I'm throwing it out here right now, but we don't really need this till tomorrow. But here's the deal. The goal to solving any equation is to get x by itself on one side of the equal sign. This x is definitely not by itself. It has a 2 right here and a 3 right there. The question is, which one do I get rid of first? The 3, right? How do we know? It's like you're undoing something. You're doing everything backwards. So normally we would multiply first and then add. Right here you want to get rid of the addition, so you want to undo that first. Or how about this? The easier way to remember this is this. What's important when you're solving an equation? X. That's like the movie star, right? Super important. The 2 is like the movie star's buddy. That's pretty cool to hang out with the movie star's buddy. But this plus 3, this bum at the corner right here, you don't care about this guy. So let's get rid of that guy first, right? So you're going to get rid of the plus 3 first by doing the opposite, minus 3. That'll cancel out. What you do to one side, you must do to the other to maintain the balance, to maintain the equality. You'll have 2x equals 2. And from there, you need to recognize that you're really multiplying 2 times x equals 2. And actually, you could even think of the answer mentally. 2 times what equals 2? The answer is 1, right? So we already know the answer is going to be 1, but let's show our work. To get rid of the multiplication of 2, we do the opposite, which is dividing by 2. That'll cancel it out. What you do to one side, do to the other. So your final answer is x equals 1. Number 2, we need to get rid of that plus 4 by doing the opposite, minus 4. Again, we do not get rid of this minus 3. Movie star's buddy, bum at the corner. Let's get rid of that bum at the corner, right? You get rid of the plus 4 by doing a minus 4. It's off balance. Now it's balanced again because what I did to one side, I did to the other. I now have a negative 3x equals, because that ended up being 0, equals 16 take away 4 is 12. And again, I recognize that right here I have a negative 3 times x. So to get rid of the multiplication of negative 3, I need to do what? Divide by what?
3.
If I divide just by 3, negative 3. If I divide just by 3, then yeah, the 3 and the 3 cancel, but that negative is still there. So we might as well divide by the entire integer, negative 3. That way it completely cancels out, including that negative sign. So check it out. Right here, the negative 3 and the negative 3 cancel. So I have x equals, over here I have 12 divided by negative 3. That is negative 4. And that is our answer for that one. Okay. How about you guys try number 3? Go for it. Again, the explanation, movie star's buddy, bum at the corner. Let's get rid of that bum at the corner first. Doing the opposite. What you do to one side, do to the other side. Bring down what you have left over. We have a negative 2x, so let's bring that down. We have the equal sign, let's bring that down. And negative 12 plus 4, you owe 12, you have 4, you can't pay them off, you're still going to owe 8. Final step is to recognize that you have negative 2 times x equals negative 8. To get rid of the multiplication of negative 2, you're going to do the opposite, which is dividing by that same exact value, negative 2. It's going to cancel. What you do to one side, you do to the other to maintain the balance, to maintain the equality. And you have x equals positive 4. And again, you could take that 4, plug it back into the original. Negative 2 times 4 is negative 8. Negative 8 minus 4, it really does equal negative 12. So you could double check it by plugging it back in to see if it really does give you that answer. If you get the wrong answer, then you know you did something wrong and you have to go back and check your work. Let's move on to the last one here. Number 4. So, where's my x at? The left side of the equal sign or the right side? It's on the left side. Is it by itself? Heck no. There's a negative 2 right there. There's a plus 4 right there. Which one do I get rid of first? The bum at the corner, that 4. So subtract 4. 4 take away 4 is 0, right? Yeah. And you subtract 4. 4 take away 4 is what? 0. So you need to put 0 here. Because if you just do this, then it's going to be blank. But 0 is a nice whole number. So it says equals 0. What's left over on the left side? That negative 2x. You bring that down. So you really have negative 2x equals 0, which really means negative 2 times x equals 0, which means that to get rid of that multiplication of negative 2, I do the opposite, divide by negative 2, divide by negative 2, and that will be x equals, now tell me this, what is 0 divided by negative 2? It's just 0. As a matter of fact, 0 divided by anything is still 0, right? 0 divided by 2 is 0, 0 divided by 50 is 0, 0 divided by anything is 0. So that's an actual answer. I mean, the number 0 exists. So the answer is x equals 0. And if you were to take that number 0 and plug it back in, what's negative 2 times 0? And what's 0 plus 4? Doesn't it equal 4? Yes, it does. You've double checked it. You're absolutely positive that the answer is 0. Okay? That's about it. Let's move on to our homework on the next video.